Hi guys, in this video we're going to be looking at using a physics design challenge in order to teach children about torsion and how torsion can be used to generate force. Now you could set this up in any number of ways. There's lots of different ways of actually creating a design challenge around this. I'm just going to give you one example though, and that's using these simple wooden splints that you get for lighting Bunsen burners and that sort of thing. They also double as a fairly easy to use building material as well, and so that's what I'm going to be demonstrating with today. What I've started off with is just by making some sort of frame. And this frame is going to support the whole mechanism that we're using. Now, you don't have to use splints. You could make a frame using anything. You could try using pencils. In the past, I've had kids bring in cardboard tubes, cardboard boxes, and trying to make their own. And basically what we're using is the torsion principle to try and make either, we'll call it a motor, or it could be used to create a sort of catapult mechanism. So you can tie it into social studies topics if you're looking at some sort of historical warfare or things like that. So once you've created your frame, in fact I'll show you quickly how I've created the frame. Here's an example. All I've done, I hope the camera can see this, is I've taken one of the splints, and they're very easy to cut. You can just cut them with a pair of scissors. And I've kind of cut a groove out the end. I've sort of bifurcated the end here, so that I can dovetail it and slot one into the other. And then you could use a rubber band, you could use a bit of string. I use string in these ones, just to lash them together. So that one is slotted into the other and then it's just been lashed. And that gives it relative stability. I just knocked these ones up in 5 minutes. Then we're actually going to explore torsion and how we can use it to generate force. So we're going to take another piece of string and just tie it around the middle of our frame here, which we'll just do very quickly. Just simple reef knot, any knot that you know. Probably not giving myself quite enough string to work with, but that'll do. Okay, so we've basically given our frame a belt. Now we can start generating force with it. So what we're going to do is we're going to insert another splint, a fifth splint in it, and we're just going to rotate it. And we have to kind of slide it back and forth so that it doesn't get caught up in the frame. But by doing this and just rotating it around, what we're doing is we're building up potential energy in the string here, because the string is wound up. We're putting energy into the string, and so it has the potential to try and unwind, at which point the energy is being released. Now I've just wound that a few times there. I could do it a few times more, but you're probably getting the point. What's happening now is it's been wound enough, it's pulling actually on the edges of this frame so much that it's starting to distort a little bit. But what I've basically got now is a very simple makeshift catapult. So I can pull it back here and it'll fling forward. Now you can make large scale versions of these, and in fact large scale versions of these exact things existed in the past. And this is one of the primary methods that was used for medieval catapults or mangonels or onagers or whatever we want to call them. So by pulling the arm back and then releasing, the force is directed forward. So it's an interesting illustration. You can do some sort of exploration into other areas of life this might be used in. But yeah, very simple, very quick, very easy sort of design challenge to set your class. Can keep them occupied for a while, or it can just be a fairly quick, here's a demonstration, now go play with it. Cheers!